Okay, so we can now move on to section 3.4, derivatives as rates of change. So remember whenever we talked about what a derivative was in section 3.1 and 3.2, we said it was the slope, right? And remember, slope is a rate of change, okay? So the derivative is going to tell me the rate of change at a certain point. And that's what I'm saying right here. It is the instantaneous rate of change. Okay, so again, it's the rate of change at that point. So let's think about how I can use that to evaluate points that might be hard. Okay, so like right here, example. If f of 3 is equal to 2 and f prime of 3 is equal to 5, then let's estimate f of 3.2. Okay, so I know that f of 3 is equal to 2, and I know the rate of change at that point is equal to 5. Remember, the rate of change is how y is going to change as I change the x. So having a slope of equal to 5, remember I can write 5 as like 5 over 1, and so this means as my x goes up by 1, my y is going to go up by the 5, right? So when I estimate f of 3.2, that's about whatever f of 3 is, and then I'm going to add how much change I'm going to have right here. So from 3 to 3.2 is a change of 0.2 times the rate of change at that point. Okay, because this is where I'm going to start. Okay, I'm going to start at f of 3, and then I'm going to do my slope, the amount of times that it takes to get to my new point, which is 3.2, which is 0.2 times, right? Because from 3 to 3.2 is 0.2. And I'm going to do my rate of change that many times. So, as we have up here, f of 3 is equal to 2, plus 0.2 times f prime, which we said right here was a 5. 0.2 times the 5 is equal to 1, so that's 2 plus 1, and 2.1 is equal to 3. So if f of 3 is equal to 2, then f of 3.2 is about 3. Let's try the same thing over here. If f of 10 is equal to negative 5, and f prime of 10 is equal to 6, then estimate 10.1. So just like I did up here, f of 10.1 is going to be about, I can start with, I believe this should say positive 10 right here. I apologize for that. That is a typo. That should say f of 10. My bad. Okay, so f of 10.1 is about, my starting point is going to be f of 10, and I need to go up by 0.1 to get to the 10.1, right? So plus 0.1 times my rate of change at 10. So f prime of 10. So f of 10 we know is negative 5, plus 0.1 times we know f prime of 10 is equal to 6. 0.1 times 6 is 0.6, so negative 5 plus 0.6. Negative 5 plus 0.6 is negative 4.4. So f of 10.1 is about negative 4.4. So one of the good things about reading derivatives as a slope is that I can apply this to a lot of really cool stuff, okay? Like this example, what I'm going to do down here, the motion along a line. Let s of t be a function giving the position at any time t. So s of t is going to tell me where my point is. So like if I'm talking about a height, right? So like the height of a ball. This is going to tell me what the height is at a certain time t. Okay, this is going to tell me where the function, where my point is. Okay, so the velocity of that is going to be v of t is equal to the derivative. Okay, because if s of t tells me where it's at, velocity is going to be how does that change? How does my position change? Because velocity is trying to tell me how fast and which way my ball is going to go, right? And so that's going to be the rate of change of where it's at. The speed is the same thing, except speed only tells me how fast. Speed does not tell me which way I go. And so speed is the same thing, except is the absolute value of v of t. Again, because v of t tells me how fast and which way. Speed is only how fast. Given all of that, the acceleration is a of t, and remember that this means how does my speed change, right? And so a of t is equal to v prime of t, again, because it's how my speed will change. And that is the same as the second derivative of s of t. So using all of that stuff, let's look at this example right here. A ball is dropped from a height of 64 feet. Its height above the ground in feet, t seconds. After that is given by the function s of t equals negative 16t squared plus 64. What is the instantaneous velocity of the ball when it hits the ground? So it's asking for a velocity, which means I'm looking for v at some point. So I first have to find what v of t is. Well, as I wrote down up here, v of t is equal to s prime of t. So I have to find the derivative of s of t, which they gave me right here. So taking the derivative of this, I can bring my power down to the front. Negative 16 times 2 is negative 32. T to the first. The derivative of 64 is 0, so I don't even need that. So that's what I have for v of t. V of t is equal to negative 32t. Now they want to know what v of t is when the ball hits the ground. So I first have to find at what time does it hit the ground. So if it's hitting the ground, the height, in this case, which is s of t, hitting the ground means s of t must be equal to 0. So what I'm going to do to find that time is do 0 equals negative 16t squared plus 64. And then solve that for t. Again, that's going to tell me what time the ball hits the ground. So to solve that, we can add 16t to the left side. 16t squared is equal to 64. Divide that by 16. And we have t squared is equal to 64 over 16 is 4. Since I have t squared, I can find t by taking the square root. And I get t is equal to plus or minus 2. However, since these are all times, I'm only going to deal with the positive one. So my time is going to be equal to 2. So at time equals 2 is when the ball is going to hit the ground. So if I want the velocity at the point in time whenever it hits the ground, I'm going to plug 2 in for t into my v of t. Again, it's asking for the velocity when it hits the ground. I now know that means they want v of 2. So to do v of 2, we're going to plug in a 2 right there. So negative 32 times 2, which is negative 64. So the velocity is negative 64 feet per second. So like I said, v of t is going to not only tell me how fast, but also which way I go, right? The minus sign out front right here means it's falling down, which we knew that because whenever a ball is dropped, it goes down, right? So like we knew that. But this shows us that. It's going down at a speed of 64 feet per second. Let's look at another example. A particle moves along the coordinate axis in the positive direction to the right. So this means on the coordinate plane that I have a point on there and I'm moving in the positive way, which is to the right. Okay. Its position at any time t is s of t equals t cubed minus 4t plus 2. Part A says find v of 1 and s of 1. I'm pretty sure that's supposed to say a. I apologize again for the typo. This should say a of 1. Apologies. Find v of 1 and a of the 1. So to find v of 1, I first need to know what v of t is. Remember, v of t is just s prime of t. So I need to take the derivative of this guy. So bring my 3 down, bring the 3 out front. That makes it 3. Decrease my power by 1. It was 3, so now it's 2. 3t squared. Derivative of negative 4t is negative 4. Derivative of 2 is 0. So v of t is equal to 3t squared minus 4. So when it's asking for v of 1, I just plug in a 1. So 3 times 1 squared minus 4. That's 3 times 1 minus 4. 3 minus 4, which is negative 1. So v of 1 is equal to negative 1. Remember, we said a of t is the rate of change of my speed, right? So that is velocity prime. So now I'm going to take the derivative of this. Bring my 2 down. 2 times 3 is 6, so that's 6. Decrease my power by 1, so I just have 6t. The derivative of negative 4 is equal to 0. So a of t is just 6t. So when I do v of 1, that's just, or a of 1, apologize. That's just 6 times 1, which is 6. So a of 1 is equal to 6. V of 1 is equal to negative 1. So using that, let's move on to part B. At t equals 1 is the particle moving left to right or right to left. So we know the positive way is moving to the right. So from the left to the right. My velocity is negative, which means I'm going backwards. So instead of going left to right, I'm going right to left. It's moving right to left because v of 1 is negative. Again, because v of t tells me not only how fast, but also which way I go. Part C is asking kind of the same thing. Is the particle speeding up or slowing down? So remember, we said a of t tells me how my speed will change, right? So this is trying to say a of t is how my velocity will change. It's my rate of change for v of t. So since that's positive 6, it's positive, which means my velocity is going up. So it's speeding up. It is speeding up because a of 1 is positive. So it's speeding up. Remember, a of t is the rate of change of my rate of change. So it's how does my velocity change. So this is positive 6. So it's speeding up. Let's use those same concepts, those same ideas for this next example. A particle's position is s of t equals t cubed minus 9t squared plus 24t plus 4. Part A just says find v of t. So for v of t, as we have said a lot of times, v of t is just the derivative of s of t. So f prime of t. Let's do that. Bring my 3 down, that makes it 3. Bring my power down by 1, so it's 3t squared. Minus 2 times 9 is 18, so minus 18. Decrease my power by 1, that's just t to the first, so t. The derivative of 24t is just 24. The derivative of 4 is 0. So v of t is equal to 3t squared minus 18t plus 24. Part B says, at what time is the particle at rest? So at rest, let's think about what at rest means, okay? At rest means it is not moving at all. If you think about what that means my velocity is 0. So what it's really wanting to know here is where is v of t equal to 0. So to figure that out, just set what we said v of t is, 3t squared minus 18t plus 24 equal to 0, and solve that. Okay. So to solve that, I see all of those have the common factor of 3. So I can divide the whole thing by 3. That gives me t squared minus 6t plus 8 equals 0. I can factor that out. I can find the factors of 8 whose sum is equal to negative 6. That would be negative 4 and negative 2. So t minus 4, t minus 2 equals 0. Set both of those equal to 0. And you get t equals 4 and t equals 2. So at t equals 4 and t equals 2, the particle is staying still, not moving at all at t equals 4 and t equals 2. Using our answers from part B, I can move on to part C. I'm going to try to make this all fit on one page. I don't know how good that's going to... Oh, that's not bad. Okay. Part C asks, on what times is the particle moving from left to right, and when is it moving from right to left? So I know when it's staying still. Okay, I know that. So why don't we make a little timeline here? I know it's staying still at t equals 2, and I know it's staying still at t equal to 4. And then I also know my time is always going to start at 0, because it doesn't make sense unless time is positive, right? So I know this is where I start, and then I know it's staying still at 2, and it's staying still at the 4. So what I want to know is what's happening between all of these. Is it moving right to left, or is it moving left to right? So to know that, what I'm going to do is I'm going to pick test points in each part of this. So from 0 to 2, I can pick a test point of 1. From 2 to 4, I can pick a test point of 3. And from 4 and everything else, I can pick whatever I want to, but let's just pick 5 so that it's as small as it can be. So what I want to know is what is the velocity at each of the test points right here. That's what I want to know, okay? So we already said from part A that v of t is 3t squared minus 18t plus 24. So if I can find what the velocity is at each of these points, 1, 3, and the 5, that can tell me which way my particle moves, okay? So the velocity of 1 would be 3 times 1 squared minus 18 times 1 plus 24. 1 squared is 1. 1 times 3 is 3, so that's 3. Negative 18 times 1 is negative 18 plus 24. 3 minus 18 is negative 15. Negative 15 plus 24 is 9. So the velocity at time equals 1 is positive 9. Since it is positive, that means at 1, I'm moving from left to right, the positive way. So everywhere from my starting point to 2, so from 0 to 2, I'm moving from left to right. Let's see what happens at 3. V of 3, that's 3 times 3 squared minus 18 times 3 plus 24. 3 squared is 9. 9 times 3 is 27. Negative 18 times 3 is negative 54 plus 24. 27 minus 54 is negative 27 plus 24 is negative 3. So since v of 3 is equal to negative 3, then at 3, I'm moving backwards. So I'm moving from right to left because it's negative. Let's look at the 5 right here. V of 5. 3 times 5 squared minus 18 times 5 plus 24. 5 squared is 25 times 3 is 75. 18 times 5 is 90, so minus 90 plus 24. 75 minus 90 is negative 15. Negative 15 plus 24 is again 9. So since v of 5 is positive, it's moving the positive way. So when it asks where I'm moving left to right, that's the positive way. Sorry, I can't write and talk at the same time. Left to right, That's the positive way. So that happens from 0 to 2. Parentheses, because I don't want to include 2, because at 2 I'm staying still, right? It's staying still right there. So parentheses. 0 to 2. And it's also going from 4 and everywhere else. Where it's moving from right to left is just between 2 and 4. Again, I'm going to use parentheses here because at 2 and at 4, I'm staying still. So it does not move right to left. So again, how I tell where I move left to right and where I move right to left is I'm going to first plot where I'm staying still and find what happens between all of those points. So I could pick any point here. I just picked a 1 because that's, clean and clear. Between 2 and 4, I picked a 3, but I could have picked like 2.8 if I wanted to. And then from 4 and everything else, I can pick whatever. So I could pick 5, I could pick 100, I could pick 1,000. It doesn't matter as long as I'm greater than the 4. Once I have my test points, plug them into the v of t and the sign of that. So like this is positive 9, and so I'm moving in the positive way. This is negative 3, and so I'm going backwards and on. So there are some other ways doing this same kind of thought. I can use the derivative as a rate of change, and I just wanted to list them here. If you ever hear marginal, that means the derivative of. So like the derivative of cost, the derivative like on and on. So I just wanted to bring it up right here. The same thing on the first one right here. I just wanted to let you know if P of t is the population, P prime of t is my population growth rate. These are the same ideas as what we had talked about, like velocity and all of that stuff, because all of these are just the rate of change. So this is the rate of change of P of t, rate of change of C of x, and on. I just wanted to list these out in case you hear any of these terms.